Okay, so for lab number 12, I did have some questions with the calculations, right? So when we were in the lab earlier today, you were given the mass of the solid as 200 grams. Then you had to weigh the mass of the empty calorimeter, right? So that mass is what we will be calling M2. You have your mass of your calorimeter and water. So after you filled your calorimeter with water, you would have weighed it again, and that would have been called M3. Then you would have taken the initial temperature of the water in the calorimeter, and that will be labeled as T1. The temperature of the solid, so that is where you would have taken the thermometer and put it into the beaker of boiling water and read that temperature. That is your initial temperature of your unknown solid. That is going to be T2. After you transfer that weight, the mass into the beaker and into the calorimeter, and covered it, that temperature that you would take, your highest steady temperature, would be called T3. So now let us look at substituting into the formula, right? So E is equal to mc delta theta, or E is equal to your mass multiplied by your specific heat capacity multiplied by your temperature change. Alright, now the heat that is going to be gained by the calorimeter, right, from the mass, and the heat gained by the water has to be equal to the heat lost by the solid, right? So with that in mind, now the heat gained by the calorimeter is going to be the mass of the calorimeter multiplied by the specific heat capacity of the calorimeter multiplied by the temperature rise of the calorimeter. Right. Also in the lab, you were given the values. So you were given the specific heat capacity of the calorimeter, which we are going to be calling CC. So the specific heat capacity of the calorimeter is 400 joules per kilogram per Kelvin. Right. And the specific heat capacity of water is 4200. So water is going to be 4200 joules per kilogram per Kelvin. Alright, so you're going to put your mass of your calorimeter here, which is going to be M2. Then your specific heat capacity of the calorimeter, which is going to be your 400 joules per kilogram per Kelvin. Now make sure the masses that you are putting into this formula is the mass that you have converted to kilograms. So this has to be in kilograms. So make sure of that. Then you are going to have your temperature change. So the temperature rise of the calorimeter. The temperature rise of the calorimeter is going to be T3, which is your highest temperature after you put that mass in there. That's your final temperature. So it's going to be T3 minus T1, which is going to be the initial temperature of the water that was in that beaker. Right? So inside of the calorimeter, the first temperature that you took, that is going to be your initial. So to get the change in temperature, is going to be T3 minus T1. Next, we are going to have to get the mass of the water. So we did not measure the mass of the water alone, but we did take the mass of the empty calorimeter, and then we took the mass of the calorimeter with the water. So you are going to take the mass of the water and the calorimeter, which is M3, and you are going to subtract the mass of the calorimeter from it. So that will leave you with the mass of the water alone, multiplied by the specific heat capacity of water. Again, ensure this is in kilograms. This is your specific heat capacity of water, which is going to be your 4200 joules per kilogram per Kelvin. And lastly is your temperature change. So the temperature change of the water is going to be the same temperature change of the calorimeter, because the calorimeter and the water were in contact with each other. So all of that now has to be equal to your heat lost by the solid. So the heat lost by the solid is going to be the mass of the solid, which is going to be M1, multiply by the specific heat capacity of the solid. Now this is our unknown. So that is what we'll be solving for. And then you have your temperature change. So your temperature change is going to be your 100 degrees minus your steady state temperature, which was T3. So it's going to be T2 minus T3. So that's the temperature change. Right, so once you put all of that in, you are going to solve for C. Once you solve for the value of C, that you are going to take that value now and you are going to do a little bit of research and determine what material that is. Right, in your discussion, please make sure so in your discussion, please make sure and tell me what is specific heat capacity. You are going to tell me what is the specific heat capacity of the solid that you found, right? So experimentally, what was the specific heat capacity you got? And thirdly, I want you to compare the value of the specific heat capacity of the material obtained in the experiment to the material let me rephrase this. Right. So you're going to compare the value of C obtained to theoretical values to deduce the material your unknown solid is made from. So those are the three things that you're going to talk about in your discussion. In your conclusion, make sure and state the specific heat capacity of the metal as well as state the type of the material that you deduced.